sa PNPP, itong 2 kwarto, nandito dati yung emergency diesel generators na kung makita mo ngayon, nahugot na dito ng napakor nung dinesisyon ng i-mothball to. So, ito isang long lead time item, no? Kung talagang paandarin natin to, dapat ma-order na yan, no? Gusto kong ipuntiriya na itong mismong gitna ng kalsada, 18 meters above sea level. Mas mataas ng konting generator room, no? Sa Fukushima, it was 6 meters above sea level, and they put the generators in a basement which is about at 3 meters above sea level. Kaya nung dumating yung tsunami, nalunod lahat yan, naging swimming pool yung generator site, di na makaandar. Yun ang nag-create ng problema. Itong 18 meters above sea level, kung tatama dito ang kaparehong tsunami na tumama sa Fukushima, hindi ito mababasa. So, immune ito sa tsunami. Kasi nga pinili ang Napot Point dahil dati dapat bagak to. Ngunit may tsunami tumama sa Mindanao nung pinaplano pa to. Kaya naisip ng gobyerno nung panahon na yon, ilipat sa mas mataas na lugar. Ito na yon. So, kasama ko, inimbita ko si Mark Nelson. Mark Nelson, isang environmentalistang nuclear engineer na masters from Cambridge University, environmentalistang ipinaglalaban ang nuclear sa buong mundo. So siya po ang guest speaker ng Alpas Pinas sa aming taon-taon na Stand Up for Nuclear event na nagaganap sa buong mundo, sa iba-ibang syudad ng buong mundo. Mark, wanna say a few words?
Sure. I have to admit that before I came to this site, I found it difficult to understand what Congressman Mark was so obsessed about. Just an old nuclear plant. Look, I'm sure so many things are wrong. I'm sure we could start from the beginning in a new location, no history, no baggage, all from scratch. Now that I'm actually here, I understand. I finally understand what you mean. Here it is.
It's built.
It's here.
Yeah. All we need to do is commission this.
Right.
And it only takes 4 to 5 years to get this plant running. And we're in the middle of a electricity price crisis.
It's not just that. As an American engineer, I come here and I see the drawings on the wall, the images, and I associate it with the time when even my country knew how to build things like this. Our capabilities have almost completely collapsed. The difficulty in building our new nuclear plant in Georgia is because basic skills were not maintained.
We're here at the beginning of the nuclear plant or any thermal plant you can go to, whether geothermal, coal, gas. Start with water treatment. We deionize the water so that it's free of all minerals that could plug up the steam generators. We are in the non-nuclear side of the plant, called the balance of plant. There's nothing radioactive here. The turbine that generates electricity, that spins the generator to generate electricity, is on top of us. What you see there, the green big thing there, is the condenser. So that's a saltwater condenser. The tubes inside are made of titanium. I want you to notice the quality of the piping, the wiring. If you go to any industrial facility in the Philippines, you will never find this quality of design, workmanship, and the way they put. Look at how everything in order is. Malinis na malinis, no? Pati yung mga alambre. Look at the cable trays. There's no plants in the Philippines that are this neat. And this is by regulation. So, this is following US NRC guidelines. This is the boundary of the balance of plant with the nuclear island. So, there's a radiation sensor there. All people going in and out are scanned for any radioactive. If I'm wearing a t-shirt and I go inside there, right? I cannot bring that t-shirt out anymore. I have to call my t-shirt now low-level nuclear waste, right? Whether it's radioactive or not, the rules are, once I bring something in there, when it comes out, no, it's like booties, socks, everything, it's low-level nuclear. That's why there's a laundry in there, right? So what's in there is in there. You don't bring it back. Once it gets out of there, it's low-level nuclear waste, whether it's contaminated or not. Notice how thick the brackets are of everything, even just a simple pipe, because this structure is built to a 0.4G seismic design basis. To give you a comparison, Fukushima was only built to a 0.18G. So this is much more stringent. And notice the walls. There's no hollow blocks. It is all buhos. Everything here is poured concrete. Look at the piping, the electrical. Very neat, right? Everything has a bend. Everything is clamped. Everything is bolted, right? Because of earthquake.
Yeah.
This is the electrical control room of everything inside the nuclear island. There's two. There's one in the other room. And that wall is a firewall, right? They have to run at the same time. If anything here breaks, right, it's redundant. But under the rules of nuclear, if anything here breaks, they have to shut down the plant and fix it first and have at least two running before they can restart. So although it can run with just one, it's never allowed to run with just one. You need the two always. If you're on the outside, it's the dome, the containment dome. That's part of the containment dome. I'll ask you to notice the gap. In 1986, when the media was here criticizing this plant, they were saying that that's a defect, that's a big crack. But it's actually a gap between the containment and this part of the plant, so that when there's an earthquake, it can move. It's really designed so that it can move. Fukushima lessons learned if we just apply the changes over the years.
So speaking of Fukushima Daiichi, I was talking to CNN yesterday, and they wanted to know why would the Philippines not have a problem like Fukushima Daiichi? It's all Pacific Rim. There are earthquakes, there are volcanoes, there are typhoons.
Yeah.
And I had to make the point that Fukushima Daiichi that event should have never occurred.
Yeah.
But because it did occur, it changes the future afterwards.
Yeah.
And the way it changes the future for the other Pacific Rim volcano nuclear plants is that everybody has that event at the top of their mind forever. Forever. It will never be forgotten among us nuclear engineers. It doesn't matter that it didn't kill anyone from radiation. It doesn't matter that it didn't injure anyone from radiation. It was still a humiliating failure, not just in Japan, but for all nuclear engineers in the whole world, in my opinion. But since that time, 11 years ago, every nuclear plant in the world
has been
changed, altered, has been increased in its security, its backup.
Yeah.
And here's the important thing. We don't know what sort of scary catastrophe is going to confront this nuclear plant when it operates in the future, but it doesn't matter because the preparations you do for a violent earthquake, tsunami, and widespread disaster like Fukushima Daiichi experienced, that preparation is going to make you tough for almost anything. Let me give you an example. Zaporizhzhia nuclear plant in the Ukraine has 6 reactors, pretty similar to this one, a little bit larger, 6 in a row. It was captured in war and kept operating as war destroyed many things all over it. War damaged the grid, and they kept the plant going. War damaged the plant itself, and they kept all the cores safe and cooled, and even restored the plant to operation and took it down, and restored it to operation and took it down, all the while making it possible for that country to feed, house, and power its population during one of the worst things that can happen to any country, an invasive war, right? Part of the reason and we're going to get a lot more reports on this soon because the IAEA is now on site at Zaporizhia. Part of the reason that plant did so well, I'm certain we're going to find, is the preparations made because of a tsunami over in Japan, thousands of miles away, led to a complete reconsideration of safety for every nuclear plant in the world, even though there were almost no injuries. Just the attention that brought to the most extreme events was enough to protect Zaporizhia nuclear plant in the middle of a war.
Yeah.
Extraordinary.
Add to that, Mark, no, or what I said in the beginning, this plant, had it been in Fukushima, would have meant that the event would not have happened at all because we're higher, we wouldn't have even gotten wet. The seismic design basis is 0.4 G versus 0.18 G. But you're right, even if actually, this plant will even improve because of the events at Daiichi.
Right. So that's another thing people don't understand about nuclear plants. Nuclear plants just sitting here, if they're operating, if they're active, they get better and better and better. Many types of power plants, many things in our life get worse and they wear out with age. Not Mark, but the rest of us do. Nuclear plants are not like that. Nuclear plants around the world tend to get better and better and better as they get older. They have higher uptime, better performance, lower operating costs, not higher operating costs. It's something that it's not, I wouldn't say it's absolutely unique to nuclear, but it's very unusual, and nuclear experiences almost everywhere in the world where nuclear plants are considered important and prized possessions, as it would be if it's turned on here in the Philippines. Yeah. Immediately, if the day this plant turns on, it would mean the Philippines moves into a different category of nations. Those with nuclear power. Those countries with nuclear powers, they're just simply in a different category from the ones that don't. It's the most sophisticated and powerful energy source in the world, and you won't be the same afterwards. You'll get a seat at different tables. That's another thing that will happen. The Philippines will be seen in a different light.
So you're saying more respected?
Oh yeah, completely. Respect is earned, and every country may tell you don't bother with a nuclear plant, but that's because once you turn it on, you will have extra respect because of it. Yeah. Your status, your rank in the world will change a bit. And not just because of the wealth the nuclear plant creates, it's just
the sophistication,
you become part of the members of countries who are sort of a brotherhood of nuclear operators, and it's now responsibility of the Philippines to help other countries operate nuclear plants well. That's the way nuclear safety works. It's everybody at the same time.
So this was mentioned as a defect because it's too low.
It's not too low.
Yeah, it should have been higher. I want to show you the annular space between the
inner lining,
the inner containment, which is a steel shell 1 inch thick. Yes, 1 inch thick, right? And the outer 1 meter thick concrete dome. So this is the concrete dome. There's a steel liner in there that's 1 inch thick. In between, there's an annular space which is connected to a filter system, which sucks. So this is always under a vacuum. Things can leak in, but they can't leak out because there's a vacuum in here. The pump that draws the vacuum passes through a filter system before being ejected. So if there's any radioactive material, it will be filtered before the air is evacuated. And nothing can leak out, it can only leak in. Okay, so that's containment. It's not one containment like my demonstration, the cacerola.
Well, you put the steel liner on.
It's concrete plus steel.
Mark?
Yes.
Which American officials have visited this plant?
NRC, I suppose, right?
Which diplomats, which politicians?
None.
None?
Yeah.
None.
Yeah, you should.
So they go blah, 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 relations, security, shared interests, and they haven't been here.
No. Okay, anyway, I want you to observe this, no? This is the welding of the inner shell. This is 1 inch thick 25 millimeter, 30 millimeter steel, okay? Look at the welding, no? I challenge you to find welding as good as this anywhere in the Philippines. Okay, now, this welding in America, when they build the same plant, they do 20% X-ray inspection. But because this was built in the Philippines, we did 100% X-ray inspection. So this plant is arguably safer than any plant built in America. For the simple reason that they didn't trust us. So they double-checked. Right? Yun ang reactor. Yun. Takip lang to, takip.
Mark,
Hi.
I feel something. This feels similar to the tour of the AP1000 in Georgia.
Yeah, because this is the grandfather of the
A
AP1000.
difference is this feels more spacious and less crowded than the AP1000 does. One of my big complaints about marketing language used to talk about nuclear plants is that if you were to hear the AP1000 boosters describe it, they say, oh, we save this much concrete, this much steel. And then I go through and I'm hitting my hard hat on things and I feel a little dizzy and claustrophobic.
Yeah.
That's worse working environment.
Yeah.
And you save almost no money. What's the point of a claim like that if it makes it worse?
Obsession with the marketing word. When they are loading or unloading fuel from the reactor, which is down there, you will be able to see it from there. No, this pool that you see here is full of water. The water is the shield from radiation of the exposed fuel assemblies. They will open the reactor, you will see the fuel will be taken out, but it's all underwater, right? After they finish the refueling, they close the reactor, everybody leaves here, they drain this water so that it's dry there, and then they start it up, right? The used fuel is brought here. You can come here and look at it here. Okay, there's a tunnel, a tube down there. They lie it down. Here can go out. This crane is used for the refueling, lifting those things in and out of the reactor. There are 121 of them there. This is just the cover. We have two steam generators, that one and that one, no? The one I showed you in the drawing, this one, that generates the steam, right? Our plant hasn't seen a single neutron, so that is brand new.
It's a plant for operating past 2100.
Yes, this will go past next century because, it's already 2022. If this is activated, 80 years. Everything in the control room is serviceable from behind. You don't have...
This is behind the control.
Yeah, you don't have to dig out the controls. You can service it from behind, right? You don't need to... The wiring is all exposed. So it's easy to maintain, right? So here we are in the control room. And if you're incoming shift, you cannot go straight in here. You have to stay there for 30 minutes. So that and then you come in during your time, the other guy goes out. And shifts here are only 2 hours. Okay, so that's the end of our tour. And this is being wasted. Wasted. In spite of a power crisis, we are wasting this. Ang pinaglalaban po natin ay nuclear energy na mapalitan ang likas na mahal na coal or gas na ini-import natin. Nandito tayo sa huli ng PNPP. Ito po yung turbina kung saan linilikha yung 620 megawatts. May krisis ngayon sa kuryente. Sobrang taas ng presyo ng kuryente. Ito, bayad na. Nung August 2007 pa, hindi po natin ginagamit. Ako ay nanghihinayang dito sa BNPP dahil nasa kalagitnaan tayo ng krisis ng kuryente. Ang laki sana ng tulong na ito na maiwasan ang napakalaking gasto sa pag-importasyon ng coal at saka gas, no? Bilyong dollar sa isang taon. Nanghihinayang ako dahil ang Duterte administration nagbigay na ng pag-aaral, nagawa na yung EO 116. Then itong bagong administrasyon sa SONA mismo ni Presidente BBM, nagbigay na siya ng suporta. Kailangan sana sundan ng ating Kongreso, magbigay ng pagpayag. Ang ating Senado, ganun din. Na ang coal and gas, sana iwanan na natin, gumawa tayo ng plano na sa loob po ng 15 hanggang 20 taon, ma-phase out yung coal at gas at maging nuclear na lahat. So kailangan natin ngayon na mag-umpisa para maisagawa ang isang nuclear fleet. It takes 6 to 7 years para gumawa ng mga bagong nuclear plant at mapaandar. So tamang-tama, patapos si Presidente BBM. Kung hindi paandarin, ito sana within 4 to 5 years aandar na ito kung papayag lang ang Senado at Kongreso. Ngunit bagong nuclear plant, 7 to 8 years. So every year gumagawa tayo ng, let's say, 750 megawatts of new nuclear power. Dahil 55% po ng kuryente ng Pilipinas ay coal imported. 20% gas, malapit na pong maubos ang Manampaya. So mag-i-import po tayo ng LNG, napakamahal po nun. Mas mahal pa yan sa coal. And so, we're talking of around 15 gigawatts, 15,000 megawatts. So, kung every year 750, mga 20 years po, by that time, wala na pong coal and gas na matitira. Murang-mura na po ang ating kuryente by that time at super reliable at super linis ang ating kuryente by that time. O pwede natin bilisan ng konti, gawin natin 1,000 megawatts per year after 2028. 2030, every year 1,000 megawatts. Habang nag-o-online yan, sinasarado natin ang ating mga coal plants. Yung mga mas bagong coal plants, pwede natin gawing reserve plants, reserve capacity, which palaging kulang sa ngayon dahil sa IPIRA. Pag-aralan po natin lahat yan. And then we will be truly fossil fuel independent. Malaki ang pagdagdag sa kakayahan natin maging isang independent na bansa. So, masyado na pong mahaba itong ating PNPP tour. Dito nagwawakas ang tour natin sa huling parte ng turbina at generator. Dito po naililikha ang 620 megawatts ng PNPP. Pagkatapos dyan, diretso na po sa mga transformer sa labas, diretso na po sa transmission line, sa mga tahanan nyo na po papunta ang kuryente nito. Mga kaibigan, ito po ay aking ginagawa para sa aking bagong apo at para sa magiging apo niya sa talampakan. Kasi po ang isang umaandar na BNPP pakikinabangan ng 80 taon pa. Kapag ito po ay na-commission, meron po siyang buhay, meron po siyang unang lisensya na 40 taon, may karapatan po siyang mag-apply sa 2 extension na tig-20 taon for a total operating lifetime of 80 years. Kung mabuksan po ito, makikita ng tao ang kaibahan ng nuclear, ang kalinisan ng nuclear, ang likas na naaasahan na pagkakuryente ng nuclear, 94% capacity factor. At ibang-iba po ang magiging perception ng tao. At kung mangyari po yan, tuloy-tuloy na po ang paggawa ng bagong nuclear plant para sa Pilipinas para mapalitan na nga ang coal and gas